congruent triangles. All right, so let's go through this. Is somebody there? Yes. Okay. So section 7, we're going to be using congruent triangles. So what we're going to do first is we're going to prove that the triangles are congruent using one of the 5 shortcuts. Side, 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 angle, side, hypotenuse, leg, angle, angle, side, or angle, side, angle. One of those 5. Once we prove that they're congruent, then what we can do is go back and prove that any other piece that didn't have a congruency mark is congruent. So here's how we're going to prove 2 segments or angles are congruent. Now, once you prove 2 triangles are congruent, again, using one of the 5 shortcuts. So I'll just write shortcuts here. Then our last statement will be whatever segment or angle they're asking us to prove congruent. The reason for that is going to be this abbreviated version of this long statement here, which states that 2 parts are congruent using the reason corresponding parts of congruent triangles are congruent. So over in the reason column, you're going to write the letters C, P, C, T, C. Make sense? That'll be a reason in your proof. Okay, those letters. So we're going to try and do a proof with this. Continue on. We're going to see how to do this. So here is our first example. It wants us to prove that angle Q is congruent to angle S. So first of all, what we're going to do is we're going to label our picture. That's what I always recommend you should do first, is label the picture so you can see maybe where we're going with this. So first it says PR bisects QPS. So QPS is this angle over here. And it's stated that PR bisects it. What does a bisector do? 2 congruent angles. So I'm going to add some congruency marks here. Then it also stated that PQ was congruent to PS. I need to find another congruent piece based on my picture. What's the obvious, Manuel?
PR is congruent to P.
By what?
Reflexive.
Beautiful. Okay, what theorem or postulate will I use, Isabella?
Side angle side.
Beautiful. Side angle side. So now we're going to set up this proof. And let's go through this. So we're going to use side angle side. And we're going to go through and fill this in. So make it a little smaller. And I'm going to start with statements and reasons. So we're going to start first by listing all our given stuff. So we're given that PR bisects angle QPS. And that's given. Then second, if you want to put it all in one statement, you can. But I'm also going to put that PQ is congruent to PS, and that's also given. If you wanted to put them both as statement 1, you can. Okay, now I'm going to show that angle QPR is congruent to angle SPR by definition of bisector. And that was the congruent angles that I filled in my picture. Okay, and then the next one is the PR, congruent to PR. And we said that was reflexive. Now we can say that what Bella told us, that triangle QPR is congruent to triangle SPQ by side angle side.
Is it SPR?
Yes, let's see, SPR. Yes, why did I put Q? Okay, yes, SPR. Same up here, this should be an R. So QPR and SPR down here, side angle side. Now, notice our proof was asking us to show that angle Q was congruent to angle S. So I'm going to write my last statement as what I'm trying to prove, and that reason is C, P, C, T, C. Congruent parts of congruent triangles congruent. Yes?
So basically you just have to solve it normally and then just put that last step at the end?
Correct. Now, back when we first learned how to do this at the beginning of the chapter, remember, the only way before we learned the shortcuts, and I'll put it back so you guys can see, the only way that we knew how to prove triangles congruent, remember we had to show congruency marks on all three sides and all three angles. So if I've already proven, it's sort of backwards. So if I've already proven that the triangles are congruent, that's telling me that every single piece in that triangle is going to have a corresponding congruent part. Does that make sense? So we're sort of working backwards. As soon as you prove them congruent, I can now go back and say, anybody still need the statements and the reasons? I'm going to zoom in on the picture. Okay. I'm going to zoom in on the picture in a minute. I'll wait for you guys. Back here, it's the same picture. On this one, the only angle that they said it bisected was this one over here. So I couldn't have said that these two were congruent off the bat just because of PR equaling PR. But on this next, so let's try another proof. All right. Now, this one looks very much the same. However, our given is different and our proof is different. So keep in mind for the test on Thursday, look at both pictures. However, my given information was different. So keep that in mind when you look over at your neighbor's test and you look at their diagram and think, oh, I got the same test. More than likely not, because I'm changing it up little by little, subtle little differences. Okay, so let's go through. Let's write the proof. Let's go ahead and label our picture first. So we have a bisector here of PR. This time, though, it's bisecting both angles. Now, over here, if I went back to this one real quick, proof, it's making this angle congruent here and over here because it's bisecting both of them, QPS and QRS. It wants me to try to prove that QR is congruent to RS. Now, what do I need to come up with to prove these congruent? What's missing? David?
The reflexive property.
Good. I need to show that PR is congruent to PR by the reflexive property. Once I do that, which shortcut am I using? Angle, side, angle. Good. Now let's get all this information into our proof. So we're going to start out with our statements and our reasons. So let's see, I'll do statements here. Reasons. So again, I'm going to start doing all of my given. So I'm going to state that PR bisects angles QPS and QRS, and that is given. So then next I could show the angles are congruent. And I can state that angle QPR is congruent to angle SPR. And this is definition of bisector. Now, if you'd like, you can put the other angle here and make it one statement, okay? Or you can separate it out and make it its own. You don't, I'm not sure how we're gonna calculate the points. If this were a question, if at this point there were 6 points, I'm not sure at this point, but I'll let you know. Okay, so you have to have it all included in here. So then the next I'm talking about is these angles down here. So angle QRP is congruent to angle SRP. And again, definition of bisector. So far I got my 2 angles in here. Now I'm going to do the side, which was the reflexive. So side PR, congruent to side PR, and that's the reflexive. Now I'm going to go ahead and put in my shortcut, which is my angle side angle. So triangle QPR is congruent to triangle SPR, or SRP, let's see. How did I do it? I did QPR, so SPR. And that is angle side angle. But it wasn't asking me to prove the triangle is congruent. It was asking me to show that side RQ is congruent to side RS. So as soon as the angle or the triangles are proven congruent, I can prove whatever side or whatever angle they're asking me to prove congruent by the CPCTC. Okay, it's not a theorem or postulate, it's like a definition almost. So congruent parts of congruent triangles, congruent. Yes?
Step 3 should be SPR.
Step 3?
Yeah.
Okay, let's see. So step 3,
Or SPR.
oh, there's 2 P's there, yes. Okay, I guess my stylus didn't push down here. So QRP and then SRP. Okay. Everybody good so far?
I needed some.
Okay. So label what's given and then try to figure out the missing piece. Whether you need to come up with another side that's congruent, another angle that's congruent, whatever you would need to prove those triangles congruent by one of the 5 shortcuts. Once you do that, again, your last statement is what you're trying to prove, and the reason for that statement is CPCTC, congruent parts, congruent triangles. So congruent parts of congruent triangles are congruent. Good?
Almost.
Okay. And we're going to do one more proof. This one the next proof looks a little different. Let's label our picture. So we are given that side WX right here is congruent to YZ, and it's also giving us that ZW is also congruent to XY. I need to prove that the lines are parallel. Okay, so what do you think we're going to do here? What do we need to, which postulate or shortcut or theorem are we using to prove that these 2 triangles are congruent? Jason?
Are you going to use the side?
Perfect. We're going to do side, side, side. How are we going to get that missing side to have a congruency mark?
Reflexive.
Reflexive. Okay, that should be the most obvious thing you should always look for when the 2 triangles are touching. All right, so let's get going here. Let's start our statements and our reasons. Okay, so we have statements. and we have reasons. Now, this proof isn't going to have the last statement as CPCTC. It's going to be the second to the last one because we're trying to prove the lines parallel, not a congruency here. So just be careful on these. All right, so here we go with our statements. First, we're going to list all our given. So I'm going to state that WX is congruent to YZ. And I'm going to state that ZW is congruent to XY. And both of these are given. So if you do them separately, two givens. Next, we'll throw in the reflexive because we need to get everything in here, our three pieces that are going to prove these two triangles congruent. So ZX is congruent to ZX. And this is reflexive. Next, we're going to state the shortcut. So we're going to state that triangle XWZ is congruent to triangle ZYX. And again, that was side, side, side. Fifth statement. I need to, what do you think I need to do? Yes.
Prove that segment WX is perpendicular, parallel to segment ZY by the C.
Nope. That's only for congruent parts. Those are parallel lines. Okay, let's think back to our, what are the ways I can prove lines parallel?
Well, can you say that the angles are congruent because the triangles are congruent?
Okay, we're going to say that the angles are congruent but first we got to figure out what?
You could use the corresponding angles converse or the alternate interior angles converse.
Good. Those were the reasons for proving lines parallel. The converse of the alternate interior angles theorem. The converse of the corresponding angles postulate. There were 5 different things that we could have used to prove lines parallel. The one that we're going to use is alternate interior angles. So we're going to state that angle 1 and 2 are congruent because of CPCTC. So we can throw that in here, angle 1 congruent to angle 2, and the reason, because we've proven the triangle's congruent, is congruent parts, congruent triangles, congruent. And then now we're going to use our converse of the alternate interiors angles theorem to prove that the lines are parallel. Because right now, here's my alternate interior, and think of this as the two parallel lines and the transversal. So now step 6 will be what I'm trying to prove, that WX is parallel to ZY, and the reason is the alternate interior angles converse. Yes?
But how would we know those two lines are parallel? We know they're parallel because they're saying that they're parallel, right?
No, they're asking us to prove that they're parallel. And we learned, remember when we learned all the angle pairs? The theorem stated that if you have two parallel lines cut by a transversal, then it makes those 8 congruent angle pairs.
Can't you only have those if we know the lines are parallel? We don't know if they're parallel or not.
But if you have 2 congruent angles that are alternate interior, then the converse of that alternate interiors angles theorem proves them parallel. So that's why it's the converse. Okay, so this one was a little different. We still had to use the CPCTC, but the last statement to prove lines parallel were those 5 reasons. Now, when we start the chapter on parallelograms, we're going to be referring back to those 5 ways to prove lines parallels. Because in a parallelogram, you're going to have 2 pairs of parallel lines or parallel sides. So these reasons, these converses of the alternate interior, alternate exterior, corresponding, 2 lines perpendicular to the same transversal, 2 lines parallel to the same transversal. All of those things are going to be reasons to prove lines parallel, and they're going to keep coming back to us. Any questions?